Okay, so today we're going to be building a full stack Spring Boot jQuery application. We'll start by going to start.spring.io. Make sure that we select Maven for our project. Scroll down and select Spring Web, Spring Data JPA, and H2 Database. Select Generate, open the folder where it was downloaded, right click, extract all, extract, open the demo folder, locate the pom.xml, open IntelliJ. From IntelliJ, select Open, navigate to the downloads demo directory, double click on the pom.xml that we located earlier. Make sure you select Open as Project. When the project begins to open, you'll see that it's importing and scanning files. Once it's done indexing the files, select Source, Main, Java, Demo Application, Run, and when the project says that it has started on port 8080, navigate to localhost 8080. According to the instructions, when we navigate to localhost 8080, we should expect to see a white label error page, which you can see here. The next step is to model the data. So we'll create a new package named model, and within that package, we'll create a class named person. Person is an entity. Person has an ID. The ID is a generated value whose strategy is equal to auto. The ID is a private long whose name is ID. The person also has a first name. The person also has a last name. The person has getters and setters for each of their fields, and that should complete the definition of our person entity. There is a claim that every entity created in Spring Boot has a respective database table that is generated in the H2 database. To view this table, we can enable the H2 console so that we can log into our in-memory database and access the live data. To do that, we'll scroll down to the section of the instructions that says view the entity, which tells us to modify the resources application.properties by adding these 4 lines. So I'll copy these 4 lines. I'll then paste them in the source main resources application.properties here. Then I'll rerun the application. Now that the application has started, I can navigate to localhost 8080 /h2 console, and using this URL, I can log into our in-memory database. Localhost 8080 /h2 console, copy the URL, paste the URL here, select connect, and now you can see there is a person table. If I select star from person and run this query, you can see there are no rows in this table. However, we can see that there are respective columns for each of the fields that we created in the person class here. Now that we've verified that we can view the entity, let's work to create a way of communicating to the database from the Spring Boot layer. To do that, we'll need to create a repository, which is Spring Boot's data access object. A data access object is a mechanism for communicating to and from the database. So this person repository that we're about to create will allow us to speak to the database from the Spring Boot layer. So let's right click, select new Java class, create a package named repository, create an interface named person repository, and ensure that person repository extends CRUD repository of parameterized type T, ID, where T is the type of entity that we would like to persist, and ID is the type of the ID of the entity that we would like to persist. In this case, person, long. And by convention, we should annotate this with @repository. The claim is that the person repository can speak to our H2 database. To test this, let's create a person config, which will run immediately before the Spring Boot application serves. And when it runs, it will add a few boilerplate person objects into the database. To do this, we'll right click, select new Java class, create a package named config. Within the config package, create a class named person config. Person config is annotated with @configuration. @configuration annotations are instantiated before the application is served on port 8080. Because they are instantiated before the application is served, we can tell it to do something post-construction, after it is constructed. And this method that we annotate here, I'll name it setup, will run before the application is served. Here, we just want to create a few person objects that we can pass to our repository to register to the H2 database. So I'll say person1 equals new person. Person2 equals new person. Person1 dot set ID 1L. Person1 dot set first name Leon. Person1 dot set last name Hunter. Person2 dot set ID 2. Person2 dot set first name Noel. Person2 dot set last name Hunter. And now that we've created these two person objects, we just need to pass them to the person repository so that the person repository can save it to our database. To do this, we'll need to inject the person repository into the scope using the @autowired annotation and declaring a field of the respective type. In this case, I'll name it repository. And now in the setup method, we can say repository save person1, repository save person2. Now when we rerun the application and wait for it to start serving on 8080, if we navigate to localhost :8080/h2-console and log into our database, then select star from person and run the query, you can see each of those records respectively. The first entry has an ID of 1, a first name of Leon, a last name of Hunter, and the second entry has an ID of 2, a first name of Noel, and a last name of Hunter. Our next phase is to create a person service, which is responsible for encapsulating the person repository and defining respective methods to be leveraged by the person controller. By convention, the service class should have support for creating, reading, updating, and deleting respective entities. We'll right-click, select New Java Class, create a package named Service, then create a class within the package named Person Service. Person Service is annotated with @service. Person Service has a person repository field. Person Service consumes a person repository upon construction, but it is auto-wired into scope. Person Service has a public person create method, which takes an argument of a person to persist in the database. The definition is very simply return repository.save person to persist semicolon. Person Service should have a public person read by ID method, which takes an argument of a long ID. And its definition is very simply repository.find by ID of ID.get semicolon. Person Service should have a public list person read all method, which takes no arguments. We'll begin by saying iterable of person all records equals repository.findAll. We'll then create a list of person called the person list. It's equal to a new array list. Then we'll use all records to populate the person list. Finally, we can return the person list. The person service should have a public person update long ID person new person data method, which is responsible for updating a person with a specific ID with some new data. We'll begin by fetching the person in the database by saying this.readById of ID. We'll then set each of the fields for that person in the database to each of the respective fields from the new person data. After setting each of the fields, we can then say return repository.save person in database semicolon. The last method that we need to define is the delete by ID method. This method will find the person to be deleted in the database by saying this.readById of ID, then telling the repository to delete that person to be deleted and return the person to be deleted so that we can use this as metadata in a response. Now that we've created a service which encapsulates all of the business logic associated with reading and writing to and from our database, we can create a controller which is responsible for handling incoming requests and outgoing responses to and from other applications. The other application that we intend to receive requests from and send responses to is our jQuery front end, which we haven't created yet, but after creating our controller, we will create and connect our jQuery application to the Spring Boot application. To do this, we'll right-click, select New Java Class, create a package named Controller, and within that package, create a class named Person Controller. The Person Controller is annotated with @REST-controller, and it has a request mapping prefix value of /person-controller. This prefix is useful because it will help organize our requests by model or domain. In this case, our model is our person. Person Controller needs a person service to get its job done. It receives the person service upon construction, and the constructor is annotated with @AutoWire to inject that person service into scope. The person person controller has a create method, which takes an argument of a person and wraps the response of the services create method in a new response entity with an HTTP status of created. Then it returns the response entity. To ensure that Spring knows to handle this method as an incoming request, we'll annotate the method with @request mapping, set its path equal to create, and its request method equal to post. To ensure that Spring knows that the person being consumed here is a JSON object, we'll have to state that this is a request body, and this path should be /create. Person controller also has a request mapping for a path that is equal to /read/ID. Its request method is get. It has a signature of public response entity of parameterized type person named read by ID, which takes an argument of a long ID that is representative of the path variable being passed in when we send the request. This name ID must match this name ID. So if this says identity, then this must say identity. The person controller's read by ID method will wrap the response of the services read by ID method in a new response entity, which consumes the response body, HTTP status, okay. Then we can return the response entity. The person controller also has a request mapping for /update/ID. And the request method here is put. The method signature is public response entity of parameterized type person. It takes an argument of a path variable of type long named ID and a request body of type person named person. The update method of the person controller will very simply wrap the response of the person's service in a new response entity, which consumes the response body and an HTTP status of okay. Then we'll return the response entity. The person controller also has a request mapping for /delete/ID. It has a request method of delete. The delete method takes an argument of a path variable of type long named ID, and the person controller will wrap the response of the service's deletion in a new response entity, which consumes the response body and an HTTP status of okay. Finally, it will return the response entity, and the last request mapping that we'll define is /read-all, which is a get request method. Here, the signature returns a response entity of parameterized type list of parameterized type person. The name of the method is read all. It takes no arguments, and the person controller will wrap the response of the read all method from the service in a new response entity, which consumes the response body and an HTTP status of okay. Finally, it will return the response entity. Now, before we wire this application to the front end, we'll want to test this using something like Postman. So I'll open Postman. I'll select new collection. I'll name the collection my first Spring application. I'll right click the collection, select add request, and I'll name this create. According to our Spring Boot application, to communicate to the person controller, we'll have to specify a URL of localhost:8080/person-controller/create. And we'll have to set the request method to post, and we'll have to pass it a JSON representation of a person object. So here we'll say localhost:8080/person-controller/create. Make sure that we've selected get, select body, from body select raw, from raw select JSON, and here we'll define a JSON representation of our person object. Our person object has an ID, our person object has a first name, and our person object has a last name. And I made a mistake. This should actually say post, not get, because the create endpoint has a post request method, not a get request method. And let's make sure that we run our application. The application is running, and let's select send. And you can see that it says the status is 201. The record has been created. Let's make sure that we select save. And now let's add another request. Let's name this request read by ID. The read by ID method has a request mapping of localhost:8080/person-controller/read/ID value. And from our previous request, we can see that the entity that was generated has an ID of 1. So if I specify /1 here and then click on send, you can see I'm successfully retrieving that data. Let's select save. Let's select add request. Let's name this request read all. The URL for read all is localhost:8080/person-controller/read-all. And the request method here is get. So we'll make sure we select get. And now when we select send, we can see 2 records are retrieved. This is because our person config has registered these 2 people into the database before the application began serving. This means that the create method that we invoked earlier wasn't the best test because we can't really determine whether or not this was an entity that was already created before it started serving, or if that was an entity that was created after we started serving and then we sent this post request. So let's just just change this data to some nonsense and select send, and then go back to the read all, select send, and now you can see that record respectively. Again, let's make sure that we save. Let's make sure that we save these requests. And next, let's add a request for updating by ID. Update by ID has a request mapping of localhost colon 8080 / person hyphen controller / update / the ID of the entity to update. In this case, let's update entity with ID of 1. This has a request mapping of put, so we'll select put, and the method consumes a JSON representation of a person POJO. So let's select body, let's select raw, let's select JSON, and let's update the first name to be someone and the last name to be else. Let's select send. You can see it has a response of 200 OK. Let's select read by ID. Let's hit send, and now you can see the data has changed respectively. Let's go back to update by ID and make sure that we select save. And finally, let's add a request for deleting. The URL for deletion is localhost colon 8080 / person hyphen controller / delete / the ID of the entity we would like to delete. In this case, let's delete entity of ID 1. Let's select delete. Let's hit send. You can see that that entity has been deleted. Let's verify that by selecting read by ID, send, and you can see we get an internal server error. If we were to select read all and hit send, you can see now one of the entities no longer exists. Let's go back to the delete method, select save, and now we've just completed our first Spring CRUD application. The next phase is to create a JQuery front end that allows us to speak to this Spring Boot web server. To begin creating our front end, we can go to source, main, resources, static, right click, new HTML file, name it index. And now when we rerun our Spring Boot application, navigating to localhost colon 8080 will result in us navigating to this HTML page. So if I write hello world here, then rerun the application, wait for the application to serve, then navigate to localhost colon 8080, you can see hello world is displayed. Now our front end can be very simple. We just need to create a single form which has an input for the person's ID. And here we can add some text to help the user. We'll say enter ID. We'll create another input for first name. We'll say enter first name. Another input for last name. We'll say enter last name. And then a button which on click will invoke a JavaScript function named create, which takes an argument of an event. We'll add text to the button which says create, and we'll create another button which on click will invoke read. The text on the button will say read by ID. We'll then create another button which on click will invoke read all, and the text on the button will say read all. We'll create another button which invokes a method named update, and the text on the button will say update. And finally, we'll create another button which invokes a method named delete, and the text on the button will say delete. We'll need to add JQuery so that we can send AJAX requests from the front end to the Spring Boot endpoints. To add JQuery, we'll just paste this snippet of code here, and we'll also import the JavaScript file that will contain each of these methods here. So now we'll just need to create this service.js, which should be sitting as a sibling to the index.html. So I'll right click, select new file, service.js. I just remembered we'll also need a place to display the output for each of these methods. So let's create a div which has an ID equal to output. One last touch that we want to add to our person controller is adding an @cross-origins annotation to the class signature. This will allow us to receive those incoming requests from the AJAX application. In the service.js, I'm going to create a person class, and the person class will take an argument of an ID, a first name, and a last name. Upon construction, we'll set this.id equal to ID, this.first name to first name, this.last name to last name. There will also be a function for updating the display with a particular response. Its definition will be document.getElementById of output, and set the inner text of that output element equal to the JSON stringification of the response. Now we're going to need to define the create method that we mentioned before. Create takes an argument of an event. We first want to tell the event to prevent any default behavior. This can sometimes cause asynchronous issues with the requests, so it's just safest to put event.prevent default as your first line. Next, we need to fetch the first name. We'll say const first name is equal to document.getElementById of fname.value. We'll copy this line, paste it, and rename first name to last name, and rename fname to lname. We'll do this again, but this time we'll rename first name to ID ID and fname also to ID. We can then say person is equal to new person of ID, first name, last name, and person data is equal to JSON.stringify of person. Now that we have the person data, we can send this as a request by saying $.ajax, open parenthesis, open curly bracket, and here we'll say type :post because the create endpoint has a request method of type post. We'll need to set the cross domain to true. We'll have to specify some headers. Ensure that the accept key is set to application/JSON. The content-type should also be set to application/JSON. Set access, control, allow, origin to asterisk. After defining the headers, set the URL to /person-controller/create. The data that we'll be passing through is person data as assigned on line 19, and the data type is JSON. If we're able to successfully run this AJAX request, then I'd like this function to run, and this function will invoke update display of response. If the function fails, I still want the function to update the display with the response. Now, we should rerun the application to test to see if this create method is actually working. But before we restart this application, I notice on line 15, we're getting element by ID of ID. However, in the index.html, we're setting ID to person-ID. So let's say person-ID. And one more thing, I noticed that we put all of these input boxes on the same line. So let's end each of these lines with a line break by saying a tag of BR at the end of each line. Now let's rerun the application, navigate to localhost :8080, enter some data, select create, and you can see the response is displayed there. If I go back to our postman, select the read all request, hit send, you can see there is now a record with some data entered into the database. Let's add one more person into the database by entering an ID of 3, selecting create, and now you can see it's created a new object in the database. If we go back to postman, select read all, you can now see 3 records are in the database. Let's continue by creating the read function. I'll copy the create function here, paste it, rename it to read, replace create with read in the URL. I'll eliminate the person data because according to the person controller's read method, it does not take an argument of a request body, and I'll concatenate to the end of this URL the ID that we retrieved on line 44. Lines 45 through 48 are unnecessary, and let's set the type of request to GET. Let's rerun the application. Let's navigate to localhost :8080, enter an ID of 1, select read by ID, and now you can see the first record is retrieved. If we enter an ID of 2, select read by ID, you can see the second record is retrieved. So next, let's create a method named read all. I'll copy the read method, paste it, rename it from read to read all, get rid of line 69, rename line 78 to read-all, and eliminate everything that trails that. And let's rerun the application. Let's navigate to localhost :8080, select read all, and now you can see 2 records appear. Next, let's create a method named update. So I'll copy the create method, I'll paste it, rename it to update, set its type to put, set its URL to /update.concat ID, make sure that it's update/ID, rerun the application, navigate to localhost :8080. Let's modify the first record by renaming it to Noel Retina and selecting update. Now you can see the first record's been updated. If I select read all, you can see there are 2 records. The first one reflects the changes that we just made, and the second one reflects the person object that was registered by the person config. The last function that we need to define is the delete function. So I'm going to copy the read function. I'm going to paste it. I'm going to rename it to delete. But as you can see, delete is a keyword. So I'll rename that to destroy. And I'll also go to the index.html and rename this as destroy. The type is delete. So we'll say delete. The URL is delete. Now let's rerun the application, navigate to localhost :8080, enter an ID of 1, select delete, and you can see this was the entity that was deleted. So if we were to select delete again, you can now see that we cannot delete that entity because it's already been deleted. So let's select read all. You can see there's only one entity that's in the database. Let's update that entity with a name of Leon and last name of Hunter. You can see that that entity has been updated. Let's select read all again. Now you can see there's a list of one entity that's been returned. Let's set the ID to 3, click create, then click read all. You can see there's now 2 entities in the database. Let's try reading the entity with just an ID of 3, read by ID. You can see that entity is returned. Enter 2, read by ID. You can see that entity is returned. So that concludes creating a full stack Spring Boot jQuery application. I hope that was useful. Thank you for watching.